In this example, we're going to find the line integral of f from the origin to 1, 1, 1 over the path c, defined here in the figure. And you'll notice that c is defined as the path of two curves. And f, my vector field, is defined as 3yi plus 2xj plus 4zk. So first, we'll need to calculate the line integral from the origin along path c sub 1 to the point 1, 1, 0. And then from that point along the path c sub 2 to the ordered triple 1, 1, 1. First, let's look at along the path c sub 1 from the origin to 1, 1, 0. So if we try to parametrize that curve, then we'll say x is t. If x is t, then my y value is t, and z remains constant, 0. And of course, we are considering t from 0 to 1. So r sub 1, my parametrized curve for c sub 1, is going to be ti plus tj, and then plus 0k, which we don't need to write, or t, 0. Then my path along c sub 2, and that's from 1, 1, 0 to 1, 1, 1. Parametrizing that, we'll have x equals 1, y equals 1, both of them remain constant, and then z goes, or is equal to t. Of course, t is from 0 to 1. So r sub 2 of t is I plus j plus tk, or rather 1, 1, t. So I have my two parametrized curve vectors, and I need to plug each of my components to create a force field F sub 1 as well as a force field F sub 2, as well as I need the derivatives of each of these. So giving myself a little bit more space, I'm going to rewrite my field here so we can see that. It was given as 3yi plus 2xj plus 4zk. Field sub 1, that's going to be 3 times t, so 3ti plus 2tj, and then we would have 0 of those z's. And my force field sub 2 is going to be 3i plus 2j plus 4tk. So I can think about this. I'll write them in my component form, 2t, or 3t, 2t, 0. And then we have 3, 2, and 4t. So now I need the derivatives of each of these r vectors. So dr dt, that would be 1, 1, 0. And that's for r sub 1. And dr sub 2 dt, that would be 0, 0, 1. So that dot product then, f sub 1 dotted with dr sub 1 dt, is 3t plus 2t, or 5t. And f sub 2 dotted with dr sub 2 dt is going to be 4t. So my last piece here would be the line integral for each of these. So we've got the integral from 0 to 1, 5t dt, and I'll need to sum that along curve 2, which is the integral from 0 to 1 of 4t dt. Right, so this is along curve 1, and that is along curve 2. And of course, we can see since these bounds are the same and the variables are the same, we can combine them together. That's the integral from 0 to 1 of 9t dt, or 9 halves t squared from 1 to 0, which gives us 9 halves. And that's how we find the line integral when the path is along two curves. We would just do each of those line integrals individually and sum them together. And it just worked out very nicely in this case that I was able to add those together at the end. As always, email me with questions, comments, or concerns.